planes, and of course segments and rays today. But today we're kind of introducing one other concept that comes with this, and it's really the concept of intersection. So when it comes to working with points, lines, planes, rays, segments, they can intersect. They can essentially run into one another. And when they intersect, oftentimes it's going to create either a point or it is going to create a line when you have things intersecting. If you have a situation where you have two lines intersecting, or it could be two segments, or it could be two rays, because remember, segments and rays are just parts of a line. When they intersect, they will always intersect at a singular dot. In a picture, what's a singular dot called in geometry? A point. They will always intersect at a point. If they intersect at all. It is possible for lines to not intersect. Now, you guys have talked about lines not intersecting in previous classes. They look like this. What do we call them? Parallel. But once you move into the three-dimensional plane, there's also another way that you can get lines to not intersect, and they're not parallel. It's known as something as skew. Essentially, they kind of do this thing. Two-dimensionally, it would look like this, but three-dimensionally, you kind of see that there's a gap between them. If you look at my arms as lines, that is. Now, we're not going to really see that showing up in pictures a huge amount with kind of tiny little, it's book assignment.
I'm going to need that information. I'm sorry to interrupt you.
Yep. Page 9, 25 through 30. Here, I'll just write it down.
No, I got it. Keep going.
Okay. So, when two lines intersect, or two rays intersect, or two segments intersect, they will always intersect at a point if they intersect. Now, when it comes to intersecting of other things, when you're trying to take, what's this thing called? Plane. When you have a plane intersecting with a line, it can do actually a couple different things. One option is that it's just laying on top of the plane. If I draw a line on top of, my note card kind of works as a plane, then the entire line is intersecting with it. But most of the time you're going to see something like this. And there is a small typo on this, and I didn't realize it, that I hadn't fixed it. This piece of the line from the edge of the plane to the arrow should be solid. When you're working with a plane and a line, when they intersect, the line can lay on top of the plane, or it can stab right through it. When it stabs right through it, you're going to start seeing things like that pop up. You're going to start seeing some dotted lines. Dotted lines occur essentially, if you look here, you can kind of see the entire pen. You can see where it's kind of going through it when I hold it up like this. But when I flatten it to look in two dimensions, essentially I hold it underneath the dot cam. Do you notice there's part of the pen you can't see? That's where the dotted line is showing up. I can see it here, dotted, 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 and all of a sudden I can see it underneath. This is showing kind of that stabbing through idea. Now, where the line and the plane intersect is just right there at a point. If you see a line intersecting a plane. If you see a dotted line of any sort, it is intersecting at the point where the line goes from being solid to dotted in the middle of the plane. The last intersection that you could see is you could see two planes intersecting. Now this is the one that tends to mess with people the most because of the fact that there's one thing that I didn't really emphasize with y'all yesterday about planes. Planes, while they are represented by this parallelogram, while they are pictured as that, in all technicality, they do extend in all directions without end. I just can't draw that. So these planes continue to go on forever. And when planes intersect, they will intersect right here. But since planes go on forever, technically this continues to extend and this continues to extend, meaning where they intersect is a, goes on forever with two arrows, line. So, key thing, when lines intersect, they intersect at a point. When you have a line and a plane, they intersect at, generally speaking, a point. Unless the line is on the plane. It's just drawn straight on top of it. That's the exception. If two planes intersect, they intersect at a line. Otherwise, the stuff you're going to see today is going to be very similar to what we did yesterday. The only difference is that you might see this extra step of where do things intersect. So, we're going to use this figure here. Now, keep in mind that this entire thing, all of this is one picture. First thing it asks us to do is name, or what are the names of the two planes pictured? When it comes to naming a plane, there's two different ways to do it. Option 1, there's a capital letter in the corner, specifically one that's not a point. Option 2, you grab 3 points that are on the plane, but they cannot all be on the same line. That one looks easier if it's available. Is there a capital letter in the corner of each plane?
A and B.
This one's got B, this one's got A. Double check. Are either A or B meant to be points in there? Nah. They don't have dots next to them. Remember that technically the intersection of two lines is a point, but it might not always show the point. But it is a point. But in this case, we don't have that, so plane A, plane B work. Because we have the capital letters in the corners, and those capital letters are not points. Question B, name the intersection of the two planes pictured. When two planes intersect, you should be telling me that the intersection is a line. I see 3 lines in this picture. Is this where the two planes hit one another? No, definitely not. That one? No. This one? Yes. What is the name of that line? There are 2 different ways to name a line. Gotta be careful of this. If they have a lowercase letter next to the arrow, you can call it by line and that letter. Otherwise, you need 2 points that are on the line. Does that line even have 2 points on it? No. Does it have a lowercase letter by its arrow? Yeah, K. Line K. And you don't have to do the fancy L like I do, that's just my thing. Next thing it asks is, why is part of the line PQ dashed? I talked about this a little bit. What's it mean if you've got a dashed line? You can't actually see that part. It's hiding behind something. It's like me holding up this and you looking at the pen and being like, well, we know that there's part of the pen right here. We just can't really see it. That's where the dotted line would go. So, we can't see it, or I prefer it's behind. Which plane is this piece hiding behind? It's behind this plane, which is plane B. You can kind of tell because by the time it gets to the end of plane B, that's where it turns solid again. Give one name for each line shown. How many lines are in this picture again? 3. That one, and don't forget this one up here. We already named this one earlier. We called it line K. What can we name this line?
PQ.
PQ. Is that the only option for a name? QP, or are there others? You can use M as well. PM, MP, MQ, QM. If you're going to do the 2-letter name, you don't write the word line. What do? Put a line on top of it. Does it have to have arrows?
Yes.
Yes. If you don't have arrows going both directions, you're either telling me a segment or array. Okay. What about that one? XY. Same idea. Or YX. Does the line PQ intersect plane B?
Yes.
Yes. If so, what is the intersection? M. Specifically, point M. If lines intersect a plane, it is most likely at a point. The exception is if the plane, or if the line was sitting on top of the plane. Okay, last question. I'm going to ask one follow-up question beyond this. But the last question that's written is, does the line XY intersect the line PQ?
No.
So, this is one that messes with people. It's on there for a reason. Do I see any place where X, Y, and PQ run into one another?
No, but they go forever.
No, but they go forever. So if I extend them, it looks like they intersect, but we actually don't know if they do for sure. When there is a plane drawn on the picture, which there is, there's 2 planes drawn on the picture here. There is something indicating that we are talking in 3 dimensions, because plane all of a sudden makes it a more complex picture. If the picture is simple like this one, where there's no plane drawn in, you can assume what you see is all you've got. When there's a plane drawn in, sometimes it gets a little more complex in the sense of now I've got those 2 planes intersecting one another. Kind of doing this thing. And then I've got the additional line XY going over the top. This additional line going over the top if I look in 2 dimensions, does it look like my pen could be touching that line? Yeah. But if I show you this way, is my pen actually touching any of that green ink. No. The challenge with when you're working in 3 dimensions is that if there's these planes pictured, the only way you know things intersect is if they're sitting on the planes, and then you can tell if they're parallel or not. If they're drawn off of the plane, the simple answer is maybe it hits it, maybe it doesn't. Because it is possible that I can angle my pen in a way where it will eventually hit the green, but I can't tell what angle that line is in the 2-dimensional picture. So, here's what we got. We don't know. Not enough information. That being said, I am not on a test or a quiz going to give you a question like this to try to mess with you. I'm talking about this because I think it's important to know it's something to talk about, but when it comes to tests and quizzes, if it looks like they're going to intersect, the answer is yes, they're going to intersect. But this is just something important that I want to talk about. Okay. Yeah, I was going to do a follow-up, but I've changed my mind. Yeah, we're going to be done right there. So, with notes, yes we are. Today's a short day of notes. Happens sometimes. Partially, though, I do have a skill builder for y'all. Now, today's assignment is your first book assignment. It is on page 9 of the textbook. It is number 25 through 34. And then there's 51 through 58. Remember your algebra review worksheet? That's the one that we in class did the kind of circle thing and passed things around. That one's due today. If you need an extension, you can turn it in up until the day of the test without loss of points. But please do not procrastinate. Please do not get yourself behind. Okay, I do have a skill builder for y'all today. Now, skill builders are... That is not your guys's. Skill builders are these mini, like, half-page quizzy little things. Yes, they are something we do individually. Yes, you have to do it and then turn it in the same day of class. No, it's not like a regular quiz that you get to retake, because these are meant to be real quick things of, yes, I know how to do it, write down all the answers, move on, or no, I don't know how to do it and we need to work on some things. These are meant to give me some feedback of where you're at on kind of helping you out, and they're also meant to be, for the most part, easier points when they pop up. This one's just on solving. So, before you start working on your homework, I want you to do this. You might want a calculator for this. You won't need it for the homework assignment, but you might want a calculator for this one. When you are done with this, it can go up here in this bin. Go ahead, grab a calculator.